Hi guys, so we're going to start inequalities, just linear inequalities and systems. So starting out with linear inequalities, some of the symbols we need to know are greater than, which is going to look like this, because like this side, like 3 is greater than 2. Less than, which would be like this, because like 2 is less than 3. Greater than or equal to is going to have a line under that, and less than or equal to is going to have a line under the less than one, because that means it could be like 2 is greater than 1, or 2 is greater than or equal to 2. That's also a true statement. So these are just the important symbols that we're going to be looking at. Some quick notes. So solutions are any ordered pairs that make the inequality true. Just like when we were looking at solutions of like equations, it's what makes the equation true. But now we're going to have more solutions, because if you get 5 on like one side, there's a whole lot of numbers that are less than 5. The answer could be 1. The answer could be 2. The answer could be -5. So there's going to be a lot more possible answers. So graphing inequalities is the way to show all of the ordered pairs that are solutions. We're going to have to do some shading, but first we're going to put the inequality into slope-intercept form. And then graph it. And the important part is that while we're putting it into slope-intercept form, you need to flip your symbol. You're like greater than, less than, all those, if you multiply or divide by a negative number. And then when we're looking at the symbols, when we're graphing, we're going to use a dotted line for less than or greater than, because the numbers on that line will not be included in our solutions. But we're going to use a solid line for less than or equal to and greater than or equal to, because the numbers on those lines can be included in our solutions. Then we're going to shade above the line for greater than or equal to, and shade below the line for less than or equal to. So this sounds like a lot, but we're going to go through an example. So if we have the example y is greater than 7 over 5x plus 5, it's already in slope-intercept form. So we're going to start off the same way we would if we were graphing a line. So we're going to start at 5 on the y-axis, and I'm going to put my point. And then we count our slope. So our slope is 7 over 5. So I can either go up 7 and right 5, which is off the graph, or down 7 and left 5. Now, the next thing to look at is drawing your line. Should it be dotted or solid? Since this has the line under it for greater than or equal to, it's going to be a solid line. And then you need to decide where to shade the graph. So it's greater than, so we're going to shade everything above the graph. So all these points that are shaded are possible solutions to this graph. So for example, the point right here is a solution. This point right here is a solution. This point right here is a solution, and so on. So that's what the shading shows us, is all the possible solutions. You can also test it out by picking a point. So let's say 0, 0. That's always an easy one to pick. And we're going to plug it into our inequality to see if it makes it a true statement or a false statement. So if you pick 0, 0, and plug it in, we would get 0 is greater than or equal to, that would just be 0, 5. Well, 0 is not greater than 5, so 0, 0 is not a solution, so that's the side that we're not going to shade. Now, we can also have systems of inequalities, where kind of like we had systems of equations, and we're going to have to graph two inequalities on the same graph, and our solution is going to be where our shading overlaps. So let's look at an example here. So y is less than 2x plus 3. We're going to start at positive 3, and then count our slope of 2 over 1. We can just keep going with this. It's a less than symbol, so it's a dotted line. It doesn't have that line underneath it. And then the other one, so less than, so we're going to shade underneath it. And then our other one is y is greater than or equal to negative 2x minus 1. So we're going to start at minus 1 on the y-axis and count our slope negative 2. So go down 2 and over 1. This one is a solid line. Because it's greater than or equal to. And then our solution is everything above it. So we're shading there. So our solution for this system is everything where the two overlap, this green area here. So come to class tomorrow with any questions you have, and we're going to keep practicing.